video, I will discuss how to make assemblies from parts that are already have been made in SolidWorks. So in this assembly exercise, we have a few parts, but the main part is our hitch mount, and then we have further parts such as the ball, the hex nut, a washer, a pin, and a pin lock, which are to be mounted onto the hitch mount. So I'll begin with the assembly. So right now I'm already in the assembly workbench, and if you start the assembly, you might see here a window that pops up, and it says and asks you to add in parts, but I crossed it out, and now I'm gonna restart with inserting components. So here now I can browse whichever part I want to include in the assembly. So I'll start with the hitch mount, and I'll just place it for now. And now if I make the origin of the assembly visible, and the origin, okay, it's already visible, but we have to show view. Now you can see that these origins do not overlap, but I want them to overlap so that these planes are coincident with the planes of the part that I just included. So I will go click first and then right click, and then you can see here it says float. Now float means that it can move around, so it's not fixed to any global coordinate system. And now I can choose this point and select this point while pressing Control, go on mates, and I can select coincident if it doesn't automatically select, but it did as a default, and then I can press OK. So mates, if I can explain a bit, it's like in Sketch we have relations, in assemblies we have mates, and these mates are used so that we can constrain each part according to already constrained parts or to the coordinate system of the whole assembly. So next I'll include more parts. So insert, browse, then I'll include the ball, press OK, and just drop it here for now. And then I want to do is show the axis and also the temporary axis. So you can see that this axis goes through the cylindrical center of it. So if this is a cylinder, then this is placed right in the center of it. And I can select this line here, press Control, and then zoom in here, select this line, click on mates, and it automatically selects coincident. Another way to constrain this could be that I select the cylindrical face and the cylindrical face of the hole, this one, and then make it concentric and press OK. It is similar, they both have a similar function. Now I press cross just to show you guys how the concentric works. So now I can move it just up and down, but these two cylindrical faces should be concentric to each other. So I can't move it left or right, even if I choose the move button and specifically try to move it. The only way I can move it is up or down in terms of the y-axis. But there's another rotational freedom, there's another degree of freedom, which is the rotational. So I can select, I can press on here, and then it can rotate. If you look closely at the coordinate system, it can rotate. It rotates. It's moving up and down also, but it's mostly rotating. So yeah, that's the function. Next up, I want to make this face and this face to touch each other. So I will do mate, select this one first, and then select here. Now it automatically selects it, and then press OK. So now it's coincident. Alright, more parts to add. I'll go with now you can add two parts at the same time as well. So if I was to add the washer and the nut, I'll press open. I can press first, I can include the nut first, and next I can include the washer. So now I can either, I'll use the center line in this mate. And you can see it's there, but it's the inside of it. So I want this face to touch this face again. So I would press OK as it's coincident. You can still rotate. I can stop that rotation, but it's not important to do so. And then again, I will select the circular surface, and this even I can select the circular surface of this to make it constrained. But you can see that it's not that good of a constraint, as it just went inside of it, but it doesn't matter because I can press OK, and I can do is hide this. I can do is hide. Now I have this nut. I can just move it outside, and then I can do is show, and it comes back again. Alright, we want this face to touch this face. How would we do it? Click on mates. First you select this face, and then you select this face here and press OK. So we have done the first thing of this whole assembly, but you can see that these things can be rotated, but you can constrain them pretty easily by using the planes in the part. For instance, I will just for now stop one of the rotation of this washer, and you can see the rotation by this small slit. So if I move this, it rotates. So what I would do is I will go in the washer and see that there's planes available. So I will click on one of them, this is the front plane of the main assembly, and this is the front plane of the washer. I will select them both, go on mates, and make them coincident. Press OK. Now if I go into the part and try to rotate it, it doesn't rotate anymore. Even if I do this here, it doesn't rotate because it is fully constrained. So most of the time you would need is 3 constraints to fully define a part. Alright, so we need 2 more parts to be included in the assembly, the pin and the pin lock. So I'll go and constrain, insert components, browse, then hitch pin and pin lock. Press open, click, and click again. Okay, so this cylindrical face has to be concentric with this cylindrical face. So go on mates, select again, press OK. So now it is constrained to it, and I don't want this rotation to happen. So it can rotate. I just want this to face downwards. So what I would do is use the planes. So I will take the top plane and the top plane of the hitch pin, go on mates, and make it coincident. So now I can just move up and inside and outside, but it wouldn't rotate. Alright, the next thing I want to do is, if I can bring this a bit higher. Okay, anyways, it doesn't matter, but I want this point here to be constrained with this point, because if I can show you guys here, so this curve has to be exactly on top of this curved surface. That's what we want. So just click on this point, click on this point again, go on mates, and it's coincident, press OK. And you see this curve is exactly on top of the other curve, so they're like they share the same center. Press cross. But the next problem is that we can still move this inside and outside. So in a real life situation, this pin would stop the motion, this pin lock would stop the motion of this pin from going outside. So what I would want to do is make one of these curved faces to be tangent to this flat face here. So I would do is mate, select this face, and then select this face, and then automatically it selects tangent. Alright, one thing I want to show you guys is that if I press OK for now, you can see that this part is exactly tangent to this face. So it's not intersecting it, but it's just lying onto the face. So one thing I want to show you guys is how to edit already made mate. So you can right click here and then go to edit feature, and now you can edit the tangent. So if let's say you guys constrained it and somehow this part goes inside of the mount, for instance like this, so you see it goes inside. The face is still tangent to this flat face, but now it's inside the mount. So what you can do is right click here, edit feature, and then it asks you mate alignment. How do you want the mate to be aligned? And you can click the opposite one and then press OK. So it reverses the direction of the constraint. Now you can see that it is still underdefined. Why is it underdefined? Because some of our parts can rotate, such as this and the nut. So I will do is constrain them, but even though when you have a thread and a nut situation, then you don't need to constrain the rotation, because in real life they are supposed to rotate. But for the sake of showing you guys how to fully define it, I'll mate them. So if I go on mate, I can also choose is one of the faces here, and then this face. No, I can choose this face here, which is flat. Yes, it's flat, and then choose one of the planes, such as this plane. Go on mates and make it parallel, not coincident but parallel. Press OK, cross, and now it doesn't rotate. And you can see the selected component is fully defined. It cannot be moved. Prompt shows up, which means this part, according to the assembly's coordinate system, has been fully constrained. And the same thing I can do with this ball, but it doesn't have any flat face, so I have to select one of the planes. So I'll select the front plane and the front plane again, go on mates and make it coincident, or I can make it perpendicular. Press OK. Now you can see that our assembly as what we wanted, and it is fully defined. You can get rid of the axis and the temporary axis and the origin, and you can save your part now. Thank you guys for joining, and hope you guys see the next tutorial video.